Welcome to this lesson on resistors. In this presentation, you will learn how to solve problems involving resistors connected in series, parallel, and mixed circuits. The common arrangement of resistors are series arrangement, parallel arrangement. Resistors are said to be in series when they are connected end-to-end, so that the same current flows through each of them. In series circuits, the total resistance is the sum of the individual resistances. The same current flows through each resistor, and the total voltage is shared across the resistors. Let's take a look at our first example. 3 resistors of 13, 6, and 4 ohms are joined in series. Find the total resistance in the circuit. This is a simple series circuit. It contains 3 resistors with resistances of 13 ohms, 6 ohms, and 4 ohms. Let's calculate the total resistance of the circuit. In a series circuit, total resistance is the sum of the individual resistances. So we use the formula, total resistance equals R1 plus R2 plus R3. So we add 13, 6, and 4 ohms. Adding them gives a total resistance of 23 ohms. This means the current must pass through a total resistance of 23 ohms in the circuit. Let's take a look at another example. 3 resistors of 3, 8, and 5 ohms are joined in series and connected to a 60 volts battery. Find the total resistance in the circuit, the total current, the voltage in each resistor. This is a simple series circuit. It contains 3 resistors with resistances of 3 ohms, 8 ohms, and 5 ohms respectively. These are connected in series to a battery of 60 volts. In a series circuit, the total resistance is the sum of all resistors. Our total equals R1 plus R2 plus R3. That is 3 plus 8 plus 5, which equals 16 ohms. Using Ohm's law, we calculate the total current. Current I equals voltage divided by resistance. So, 60 volts divided by 16 ohms gives 3.75 amperes. Next, let's calculate the voltage across each resistor. Remember, in a series circuit, while the current flowing across each resistor is the same, the voltage in each resistor is different. To find the voltage, we use the formula, voltage equal current times the resistance of each resistor. To find the voltage across R1, we multiply current by resistance. V1 equals 3.75 amperes times 3 ohms, which gives 11.25 volts. Next, the voltage across R2. V2 equals 3.75 amperes times 8 ohms. That gives us 30 volts. Now for R3. V3 equals 3.75 amperes times 5 ohms. That equals 18.75 volts. Now let us check our final result. Add the voltages, 11.25 plus 30 plus 18.75. That equals 60 volts. This matches the voltage of the battery, so our answer is correct. Resistors are in parallel if all their heads are connected together, and all their tails are also connected together. Each branch gets the same voltage. In parallel circuits, the total resistance is found using reciprocals. Voltage is the same across all branches, and total current is the sum of branch currents. Let's take a look at our first example on resistors in parallel. A battery with a 12 volts and negligible internal resistance form a parallel circuit with a network of 3 resistors, 2, 4, and 6 ohms. Calculate A. Total resistance. B. Current in each resistor. C. The total current. So, we are given a parallel circuit powered by a 12-volt battery connected to 3 resistors, 2 ohms, 4 ohms, and 6 ohms. We will find the total resistance, the current through each resistor, and the total current in the circuit. To calculate the total resistance in a parallel circuit, use the reciprocal formula. 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Now, substitute the resistor values. 1 over 2 plus 1 over 4 plus 1 over 6. Convert each fraction to have a common denominator of 12. So we get 6 twelfths, 3 twelfths, and 2 twelfths. Adding them gives 11 over 12. Now, take the reciprocal of 11 over 12. 12 divided by 11 equals approximately 1.09 ohms. Next, we find the current through each resistor using Ohm's law. Current equals voltage divided by resistance. Since it's a parallel circuit, voltage across each resistor is the same, 12 volts. Current through the first resistor is 12 divided by 2, which equals 6 amperes. Current through the second resistor is 12 divided by 4, which gives 3 amperes. Current through the third resistor is 12 divided by 6, which equals 2 amperes. Finally, add all the branch currents. 6 plus 3 plus 2 equals 11 amperes. That is the total current flowing from the battery. Let's take another look at another example on resistors in parallel. 3 resistors of 4 ohms, 12 ohms, and 6 ohms are connected in parallel. The total current is 12 amperes. Find the current through each resistor. This is a parallel circuit containing 3 resistors of 4 ohms, 12 ohms, and 6 ohms, connected between points A and B. The total current flowing through the network is 12 amperes. Let's calculate the current through each resistor. In a parallel circuit, each branch receives the same voltage. So, we'll first find the voltage across any one resistor. Then use it to calculate the current through each branch using Ohm's law. To find the voltage, we first calculate the total resistance. Using the parallel formula. 1 over 4 plus 1 over 12 plus 1 over 6 equals 6 over 12. So the total resistance is 12 divided by 6, which equals 2 ohms. Now use Ohm's law to find the voltage. Voltage equals total current multiplied by total resistance. 12 amperes times 2 ohms equals 24 volts. This is the voltage across each of the resistors. Now calculate the current through each branch. Using the formula. Current equals voltage over the individual resistance. So the current through the 4 ohm resistor is 6 amperes. Through the 12 ohm resistor is 2 amperes. And through the 6 ohm resistor is 4 amperes. Now you understand what resistors in series and parallel are and how to calculate them. Don't forget to like, share and subscribe. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.